Alright, we have another question here. We have y equals to sine x. Now, how do you go about that? So we have, whenever I differentiate y is y plus change in y, then equals to, we have sine, then we have 2. S there is a variable, which gives us s plus change in x. So from there, you may change in y the subject of the formula. So it becomes change in y equals to sine, then 2x, bracket s plus change in x, then minus y. So we have change in y equals to this, this 2 is affecting everything here, becomes sine, 2 times 7 gives us 2s plus 2 change in x, then minus sine 2x. So whenever you have expression like this, don't forget, I told you that you can make use of this formula. Whenever you have sine c minus sine d, so you say it in as 2, then cos half. Then we have brackets c plus d, and sine half, then c minus d. This time around, our c is sitting as 2s plus 2 change in x, while our d is sitting as what, 2x. So you cannot substitute this into this what expression. So we have change in y equals to sine. Then, we have 2, then cos half. Our c is sitting as 2s plus change in x, then plus 2 what, x, which is our d. We have sine half, then bracket c is sitting as 2x plus 2 change in x, then minus 2x. So from there, our change in y equals to 2 cos. So this sitting as half, bracket, this sitting as 4s plus change in s, then sine, we have half. So this can cancel out this, so we'll be left with what, 2 change in x. So from there, we have change in y equals to 2 cos. Don't forget, this one is affecting everything here. It's sitting as 4s over 2, then plus change in x over 2. Then this sitting as 2 can cancel out 2, will be left with sine what, change in s. Then after that, I can divide through by change in s. But before that, this sitting as change in y equals to 2 cos. This can cancel out this. We are left with what? 2 is left there, which is 2x plus change in x over 2. Then we are left with sine what? Change in x. So dividing through by change in s, it becomes change in y over change in s equals to 2 cos, bracket 2s plus change in x over 2, then sine change in x. This sitting as what, change in what, x. So we are changing y over change in s equals to 2 cos, bracket 2s plus change in x over 2, bracket sine, this sitting as change in x divide, which is this divide, divided by change in what, s over 1. When we are changing this to times, 1 will move to numerator, and change in s will move to what, denominator. So we are changing y over change in s equals to 2 cos 2x plus change in s over 2. So from there, it becomes sine change in s times 1 over change in x. So this sitting as change in y change in x equals to 2 cos 2s plus change in s over 2, then sine change in s over change in s. Change in s times 1 is change in s, all over change in s. And in my previous video, I told you that whenever you add sine change in s over change in s is equivalent to what? To 1. So this is sitting as change in y over change in s, then equals to 2 cos. So this is sitting as 2x plus change in s over 2, then times 1. So this time around, even after this, we are still having change in s in our what, expression. What you will do, you can limit change in s to be what? 0. So from there, you can simply say limit change in s approaches 0, then it becomes 2 cos, changing y over changing s equals to 2 cos. Then we have 2x plus changing a becomes 0 over 2. Everything here times 1, you still have that same thing. So from there, our dy dx becomes 2 cos 2s plus 0. So our final answer becomes 2 cos 2s. So that is our answer. Thank you very much. So let's move down to the next question. Alright, we have another question here. We have y equals to 3s plus sin 2x. Alright, so whenever you differentiate your y, you have y plus changing y. Then equal 3. If you differentiate s, you have s plus changing what? X. Then plus this sitting as sine. Then 2 bracket s plus changing what? X. So from there we have y plus changing y equals to 3 times s sitting as 3s plus 3 changing x plus this sitting as sine, which is 2x, then plus 2 changing x. So this time around, make our changing y to the solid of the formula. It becomes changing y equals to 3s plus 3 changing x plus sine, then 2s plus 2 changing x, then minus y. So our changing y becomes 3x plus 3 changing x plus sine bracket 2s plus 2 changing x minus y sitting as what? 3s plus sine 2x. So this time our changing y becomes 3s plus 3 changing x, then plus sine 2x plus 2 changing x, then using minus to open all this bracket become minus 3x and minus sine 2x. So this time around, these can cancel out this. Once it cancel out, we are left with changing y, then equal 3 changing x. Then from there we are left with 3 changing s plus sine 2x plus 2 changing x, then minus sine 2x. I gave you an expression in my previous video to use whenever you're having an expression like this or equation like this. Okay, you apply whenever you have sine c minus sine d, is sitting as 2 cos half c plus d and sine half c minus d. Okay, applying this expression in this very part of the question or of the solution, it becomes changing y equals to 3 changing s, then plus we have 2 cos half. Then our c is stating as everything here, which is 2s plus 2 changing x, then plus yd is sitting as what? 2x, then sine half, then bracket our c is sitting as 2x plus 2 changing x minus 2x. So this time around, changing y equals to 3 changing s, then plus 2 cos half. Yeah, 2s plus 2l will give us 4x plus 2 changing x. So from there it becomes sine half. This can cancel out this, so we are left with what? 2 changing x. So from there we have changing y, then equals to 3 changing x, then plus 2 cos. Don't forget these 2 is affecting everything here, so it becomes bracket 4s over 2, then plus 2 changing s over 2. So we have sine half. 1 times 2 changing, we have 2 changing x, over 2. So we are changing y equals to 3 changing s, then plus 2 cos. This can cancel out this and this cancel out this. If this cancel out, we are left with what? 2. Which is 2 what? We are left with 2s. Then plus what? Changing what? X. So from there, 2 can cancel out 2. We are left with sine changing x. Then after that, don't forget you divide through by what? By changing s. Dividing through by changing s, it becomes changing y over changing x equals to, here becomes 3 changing s over changing s, then plus 2 cos 2s plus changing s, then sine changing s all over changing s. So this is stating as changing y over changing s equals to, this can cancel out this, will be left with 3, then plus 2 cos bracket 2s plus changing x, then times changing x. This stating as times 1 all over changing what? X. Okay, so from there we are changing y over changing s, then equals to 3 plus 2 cos 2s plus changing x, then we are left with sine changing s over changing s. Changing s times 1 is changing s all over changing x. I've told you in my previous video that whenever you have changing s over changing s is equivalent to what? To 1. So from there, alright, it becomes changing y over changing x equals to 3, then plus 2 cos 2s plus changing x, then times what? Times 1. We give what? Changing y over changing x equals to 3 plus 2 cos 2x plus changing what? X. So now that you are still having changing s in your expression after you divide, you cannot limit it to be what? 0. It becomes limit of changing s approaches 0. Changing y over changing x equals to 3 plus 2 cos brackets 2s plus 0. So our dy ds is going to give us 3 plus 2 cos 2s plus 0 is sitting as what? 2x. So that is our final answer. Alright, for this, whenever you have y plus changing y equals to sine bracket sine 3 bracket s plus changing what? X. So we have y plus changing y equals to sine 3 times this, we have 3s plus 3 changing x. So from there, our changing y equals to sine bracket 3s plus 3 changing x, then minus y. Now this time around, our y is sitting as sine 3x. So we have changing y equals to sine bracket 3s plus 3 changing x, then minus sine 3x. So from there, you can apply the what? This expression, sine c minus sine d, then equals to, it becomes 2 cos 1 over 2, then sine 1 over 2 c plus d, then sine 1 over 2 c minus d, where your c is sitting as 3s plus 3 changing s and d sitting as 3x. So changing y becomes 2, then cos 1 over 2. So our c is sitting as 3x plus 3 changing x, then plus d sitting as 3x. So we have sine 1 over 2 at d sitting as 3s plus 3 changing x, then minus d sitting as 3x. So from there we have changing y equals to 2 cos 1 over 2 bracket 3s plus 3x, we give us 6s plus 3 changing x, then sine 1 over 2. This can cancel out this, so we are left with times 3 changing x. So from there we have changing y equals to, this is affecting everything here. It becomes 2 cos bracket 6x over 2 plus 3 changing x over 2. Then sine, this is written as 3 changing s over 2. So from there, this can cancel out this. Once cancel out, we are left with changing y equals to 2 cos. So we are left with 3x plus 3 over 2 changing x. Then sine 3 over 2, 3 changing s over 2. Now after that, the next step, you divide through by what? By changing x. Dividing through by changing s, it becomes changing y over changing s equals to 2 cos 3s plus 3 over 2 changing x, then sine 3 changing x over 2, then all over changing x. So from there we have changing y over changing s equals to 2 cos bracket 3s plus 3 over 2 changing x. Then y this, it becomes sine 3 changing x over 2 times 1 over changing x. Alright, so from there we have changing y over changing s equals to 2 cos bracket 3s plus 3 over 2 changing x. Then this is written as 3 over 2, then sine changing x over changing x. Don't forget, changing s over changing s is equivalent to what? 1. So from there, it becomes changing y over changing s equals to 2 cos 3s plus 3 over 2 changing x, then times 3 over 2. So from there we have changing y, changing s. So this 18 at 3 times 2 will give us 6 over 2, then cos 3s plus 3 changing s over 2. Okay, we have changing y over changing s, then equals to 3 cos 3x plus 3 changing s over what? 2. Now that we are still having changing s, you can limit it to be what? 0. So we have limits of changing s approaches 0, then becomes changing y over changing s, then equals to 3 cos 3s plus 3 brackets 3 over 2 bracket 0. Then we give us dy dx, then equals to 3 cos, then 3s plus 0, because 3 times 0 is 0, and 0 divided by 2 is what? Is 0. So from there it becomes dy dx equals to 3 cos 3s plus 0 is written as 3x. So that is the final answer. In some cases they will write it as cos 3 times 3, which is what? 9x. It's still the same thing. All right. So that's all for differentiation using first principle. Okay, maybe in our next class we'll move down to general equation, general method of differentiation, where you also have your product rule, your coefficient rule, your composite rule, function of a function, all of them. And please don't forget, please don't forget to hit the subscribe button, and also like, comment and share for more videos. Thank you.